Welcome to this lesson on COVID-19 and science. Today we will consider questions like, what is science and how is science a social process? How does scientific knowledge change over time? What shifts in thinking have shaped our current belief in scientific facts? Who is not listening to scientific expertise during COVID and why? And how has COVID-19 re-entrenched existing gender disparities in the production of scientific knowledge? Many things likely come to mind when hearing the word science. Perhaps you're imagining a white lab coat, microscopes, and beakers. While these images reflect some aspects of science, science consists of much more than this. The word science is derived from the Latin root word scientia, which means knowledge. As such, science is defined as any system of knowledge that is concerned with the physical or social world and its phenomena. Science can be understood as both a process and an entity. As a process, science is a system of acquiring knowledge through various methods of inquiry. As an entity, science is an accumulated body of knowledge that allows us to construct a coherent and comprehensive understanding about the world. The sociology of science sees science as a social institution and sees the construction of scientific knowledge as a collective activity, shaped not only by scientists themselves, but also by politics, institutions, peer review, and other social factors. The sociology of science deals with social conditions and effects of science, and with the social structures and processes of scientific activity. Sociologists of science are interested in questions such as, how did this particular tradition of modern science emerge and become institutionalized? How is science maintained and controlled? How is research organized? What determines changes in scientific organization? And how are these changes related to research? And these are not new questions. Scholars from a variety of disciplines, from sociology to philosophy to history, have thought about the construction, progression, and production of scientific knowledge. In thinking about the ways science is produced and understood today, especially amid a global pandemic, Kuhn's model of scientific change is particularly useful. Thomas Kuhn was an American historian, philosopher of science, and physicist, most well known for his pivotal work on the structure of scientific revolutions from 1962. In this text, Kuhn proposes an alternative way of understanding changes in science. At the time, the dominant view was that science was a cumulative, linear process in which individual scientists built on the work of the scholars who came before them. Kuhn, however, argued that science was actually structured and revolutionary rather than linear and evolutionary, and proposed a model to understand scientific change, what we know today as the Kuhnian model of scientific change. According to Kuhn, scientific change happens in phases, and we'll go over these phases in the following slides. Kuhn argues that all science begins at the pre-scientific phase, shown here in the top left. At some point, the science will move on to normal science. Once this happens, the science will never return to the pre-scientific phase. In other words, the pre-scientific phase happens only once, while all the other phases happen repeatedly. From the phase of normal science, science then moves on to a phase of crisis. From the phase of crisis, science can either return to normal science or move on to a scientific revolution. After a scientific revolution, the science will move on to a new normal science, a new crisis, and the cycle repeats itself. To understand Kuhn's model, it's important to first understand what normal science is. So that is where we'll begin before getting into the other phases of this model. Normal science is the usual state of science. It's characterized by a shared commitment to intellectual puzzles that are deemed worth pursuing, and a shared commitment to the methods and instruments that provide scientists with answers. During normal science, there are a set of theories, concepts, conventions, methods, and assumptions that all scientists within a scientific community agree upon and take for granted. For example, in physics, there is an assumption that an attractional force called gravity exists, and that it exerts a force of 9.81 meters per second squared on the Earth's surface. This foundational assumption guides the type of inquiry that occurs within that discipline. The foundational assumptions or set of conventions that a scientific community agrees upon is what Kuhn calls a paradigm. Paradigms provide the intellectual structure upon which a science is based, and they shape the scientific research produced in that discipline at the time. In short, normal science is defined by the existence of a paradigm that is supported by a scientific community. But before a science can reach the phase of normal science, Kuhn argues that it must first begin at the pre-science phase. The pre-scientific phase is the phase before the existence of a paradigm. Without one mutually agreed upon paradigm, there are no set of shared theories, methods, assumptions, or conventions among scientists. Kuhn calls this phase of science immature science because there's disorganized activity due to competing paradigms. Since scientists are functioning within different paradigms, competing schools of thought emerge, and scientists have different perceptions of what questions are even worth pursuing in the first place. Kuhn argues that this phase of science isn't productive because scientists can't work together, so they're unable to build on each other's findings. However, at some point, something generally happens within a scientific community, such as a very compelling finding within a particular paradigm, which results in scientists agreeing on and being confident in said paradigm. When this happens, the science moves from the pre-science phase to normal science, and all scientists begin working within that single paradigm. However, paradigms don't last forever, so a science doesn't remain in a phase of normal science indefinitely. The phase that follows normal science is the phase of crisis. A crisis happens when scientists begin to start doubting their own paradigm. During normal science, scientists are confident that the prevailing paradigm will allow them to solve their intellectual puzzles. However, during a crisis, scientists lose this confidence. The crisis phase is characterized by the presence and persistence of anomalies. Kuhn introduced the term anomaly to describe a scientific observation that doesn't fit into any existing paradigm. In other words, anomalies are differences between observed and theoretically expected data, what we see and what we expected to see. They are problems within an existing paradigm that scientists are unable to solve at a particular moment in time. The existence of anomalies isn't a problem per se. Kuhn argues that all science comes up against these anomalies. So long as scientists are confident that the anomalies will be solved in due time, they are part of normal science. However, when that confidence begins to die, and scientists become doubtful that they will be able to solve the anomaly within the existing paradigm, it is only then that science moves into a crisis. When this happens, the expectations governing normal science are disrupted, and those within the scientific community begin to question and even become critical of the fundamental assumptions of the existing paradigm. So, in times of crisis, scientists look for other ways of knowing and begin to think outside of their existing paradigm. The scientific version of thinking outside the box. Kuhn notes that there are two ways to end a crisis. The first way is that the anomaly is solved within the existing paradigm. When this happens, trust is restored in the existing paradigm. The scientific community goes back to normal science, and the crisis is resolved. The second way a crisis ends is that the anomaly is solved by a new paradigm. If the majority of the scientific community embraces this new paradigm and rejects the old one, then the science moves into a scientific revolution. Scientific revolutions are characterized by a paradigm shift whereby there is a change in basic assumptions within the ruling theory of science. In other words, the old scientific paradigm is abandoned and replaced by a new one. Scientists come to accept this new paradigm and begin to see the world a new way. Kuhn argues that old and new paradigms are incommensurable, that it is not possible for past and present frameworks to be compared. Kuhn has been critiqued for this problem of incommensurability, as some scholars believe that he exaggerated problems of comparison across paradigms. After a scientific revolution, there is a new normal science, and a new paradigm begins to guide scientific activity. After this, a new crisis will inevitably happen again, and the cycle repeats itself. If we think about Kuhn's model of scientific change in the context of the sociology of science, we can see how science is truly a community activity, and how truth is so dependent on the social context in which knowledge is produced. We also see how paradigms influence what we see. Paradigms are socially constructed frameworks within which a science operates, which means that individual scientists, professional bodies, specialized journals, funding, politics, and other institutions all shape the prevailing paradigm at any moment, and thus shape the construction, progression, and production of scientific knowledge. If we relate Kuhn's model to the contemporary context, particularly in relation to scientific knowledge production in a post-truth era, it raises the question as to whether our belief in scientific knowledge has been shaped by a paradigm shift. And the evidence suggests that it has. Science has historically been perceived as an objective discipline, and scientific knowledge as impartial and absolute. However, in the past decade, we have witnessed public confidence in the veracity of science decline, and in recent years, the simultaneous rise of alternative facts and fake news. Scholars characterize this contemporary moment as the, quote, post-truth era, defined as a moment in which objective facts are less influential in shaping public opinion than appeals to emotional and personal belief. So despite us living in a moment where we have more access to scientific knowledge than at any other point in history, anti-scientific rhetoric is still rising. We can look at the examples of climate change deniers. On the left here, we see a tweet from the United States president. And on the right here, we see a photo from an Australian rally against a carbon tax. We can also look at the example of anti-vaxxers, shown here in Vogue magazine, as well as The Guardian. And more recently, anti-maskers are a case in point. We see here CTV News coverage, anti-mask rallies held across Canada despite increased support for mandatory masks. So with the rise of anti-science rhetoric in a moment of unprecedented volumes of scientific evidence, it begs the question, what paradigm shift has shaped our current belief in scientific facts? The answer to this question fundamentally deals with knowledge claims. How do we come to know and to believe something? What kind of knowledge is valid? What kind of knowledge is reliable? These are fundamentally epistemological questions. Epistemology is the study of knowledge, or a theory of knowing. It is interested in how knowing happens, how we come to know what we know. Epistemology involves a set of assumptions about the knower, the known, and the relationship between them. In other words, the process of knowing. Epistemological questions are concerned with things like, what does it mean to know something? How do we know what we know? How is knowing enabled and constrained? What kind of knowledge is valid and reliable? Positivism has historically been the dominant epistemology in science and is deeply ingrained in popular perceptions of science. So, what is positivism? Positivism is an epistemological framework and assumption that sees reality as being independent of our experience of it. It assumes that there is an objective reality out there that we can gain access to through science. Because positivists see the world as being governed by underlying regularities and natural laws, positivists see scientific facts as objective, empirical outcroppings of the natural world. That is to say, positivists see facts as objective, impartial, and freestanding. As Sprague wrote in 2005, scientifically empirical observations, or facts, are outcroppings of the underlying regularities assumed to exist in the natural or social world. Over the past few decades, there has been an epistemological paradigm shift, whereby positivism is no longer seen as the epistemology, but as just one epistemology among many others. While positivism is still arguably the dominant epistemology in many sciences, other ways of knowing have gained popularity in a variety of academic disciplines. On the screen is a simplified version of an epistemological continuum, with positivism on the left side and social constructionism, or just constructionism, on the right. While positivists see scientific facts as objective and freestanding, social constructionists see scientific facts as being socially created through research processes conducted by humans and specific tools. While there is much debate within social constructionist work, on the whole, it's fair to say that social constructionism doesn't see reality as being rooted in nature itself, but rather as a product of humans' own making. Social constructionists believe that the social world was created by humans. This includes categories, labels, culture, knowledge, and institutions. Constructionists see institutions such as science as producers of the social world that they claim to just study objectively. Because of the active involvement of various social actors and factors in the construction, conduct, and production of scientific research, social constructionists see science as a subjective process and see scientific facts as being socially produced. Constructionists see facts as networked. The idea that facts don't stand alone, but are shaped by the actors, institutions, and other social processes and time periods that produced it. Kaufman, 2018, wrote, "Facts are networked. They stand or fall not on the strength of their inherent veracity, but on the strength of the institutions and practices that produced them and made them intelligible. If this network broke down, the facts would go with them." We'll end with this quote from your Kaufman reading, which sums up this idea of facts as being networked really well. In the author's discussion with Bruno Latour, he notes that, quote, "Facts remain robust only when they are supported by a common culture, by institutions that can be trusted, by a more or less decent public life, by more or less reliable media. It has become clear that whether or not a statement is believed depends far less on its veracity than on the conditions of its construction. That is, who is making it, to whom it's being addressed, and from which institutions it emerges and is made visible." How does this quote relate to the production and interpretation of scientific knowledge under COVID-19? Our guest lecturer for this module is François Lachapelle. Lachapelle is a PhD student in the Department of Sociology here at UBC, the co-founder and lead data scientist at Relational Academia, an innovative higher education data startup, and a research fellow with the Center for Chinese Research at the Institute of Asian Research and the Higher Education Research Group. Lachapelle's research interests are in sociology of intellectual and academic life, social network analysis, computational social science, big data, history of social sciences, sociology of science and technology, critical bibliometrics, and modern China studies. In this lecture, we'll have the opportunity to explore and analyze the following questions. How does social trust shape the public's confidence in scientific expertise and authority? What social processes may undermine social trust? Who is listening to scientific expertise during COVID-19? Who is not listening, and why? Why do people buy into conspiracy theories during a pandemic? How has COVID-19 exacerbated existing gender disparities in the production of scientific knowledge? And what are the individual and systemic implications of women researchers publishing less scientific papers during and about COVID-19?